Students, good morning to all of you. Students, in today's topic, we are discussing about the lenses. Okay. Lens is today's topic. Now, what is lens? So, lens is a spherical transparent medium which have two characteristics or two types. One is convex and second is concave. Okay, convex lens has characteristics. It has bulge at middle and thin at the ends, and concave lens have characteristics that it is depressed at middle, okay, and thick at extremes or ends. Okay, now the types of lenses, types of concave lens, types of convex. Convex, we have three kinds of lens, like plano-convex, it is like this. One side of the plano-convex lens is plane and other is with a bulge. Second, we have concavo-convex. Okay, this one side is concave and other side is convex. This is called concavo-convex. And third is biconvex. Which is both sides are having a convex surface. This is the type of convex lens. Similarly, here we have plano-concave. This is plane at one end and one end is like a concave. Second, convexo-concave. Okay, this is convex at first end and in the second end it is concave. And third is biconcave. It is depressed or concave surface in both sides. These are the types of lenses. Now we understood about the characteristic of four types of lenses and their meaning. Okay, characteristic and meaning. It is most important to understand the behavior of the lens and their properties. Okay, now we have first one. Okay, if we have a convex lens, we have not done till the part of the, suppose we have this upper part of the lens and this is the lower part of the lens. Okay, if the light is traveling parallel to it like this, then it behaves like the light is bent. See here, this is normal, okay, and this is the another normal. The light should travel in the straight path, but the medium of the lens is denser compared to the air, so it will bend towards normal. And thereafter, this is the second normal and the light should have to go here, but it comes out from denser to rarer medium, so it needs to bend away from normal. Clear? Now you will see that the light is traveling through the convex surface, it bends toward the base, okay, and for the second ray of light with incidence, we observe it is also bent here, okay, and if the other rays which are traveling, we observe these four rays are traveling from the same point, okay. Now here the nature of the lens is observed that all the light which is traveling parallel to the lens is focused or at a single point or contract at a single point. This contraction is called convergent nature or converging nature. Converging nature of a convex lens. And second, the point at where all the rays are contract by the lens is called its focus point. It is clear? Secondly, if some rays which are traveling from focus, like this is its focus point, we observe here if the rays are traveling from its focus, many rays or either, we observe that these are traveling parallel to the principal axis after refraction. This is the second nature of the lens. Now, second we have concave lens. Now we understood about the nature of concave lens. Okay. Concave lens you assume as an inverted prism. Okay. I will just show you how it is assumed like a inverted prism. If this line is contract, then you will get like a prism. Okay, so it is here like a inverted prism. Now, if the light is traveling parallel to it, okay, it is of what observation is on the concave. This is its norm. It is clear or not? Now, the light should have to travel in the straight path, but when the light is traveling from rarer to denser medium or medium of the lens, we observe the light is bends away. And at this point, this is the actual path and this is normal. Clear or not? This is normal. Then light should have to bend away from normal. So it will bend like this. Okay, and the another ray which is traveling parallel to the left, this is the principal axis. So we observe it is also bends away, and similarly if more rays are traveling, then it bends like this. Okay, then what you observe the nature. So concave lens have a dispersion nature, or we say that have a nature of spreading of light. This spreading is known as diverging nature. Diverging nature. Okay, this is nature of the convex. Now, here this point is actual meeting point. Okay, actual meeting. Actual meeting matlab the rays after refraction contract at a single point itself. This is called, hence the focus of the convex lens is called real focus. It is clear or not? This focus is real. Now, in the second case, it is observed that the rays which are passing through the concave mirror not actually meet, but they are appears as coming from the focus. Okay, so this is not actual meeting, ठीक है, not actually intersect, actually coming from F, appear to coming from, appear to coming from F. Here, so the nature of the convex lens is virtual focus. Virtual focus. It is clear or not? Concave lens has the nature of virtual focus. Second, the focal length for concave is toward right, so it is positive, and for the concave lens it is toward left, so it is negative. These things are clear or not? Now we understood about the image formation by the lenses. Okay, note down it. Yes, correct? Okay, second thing, because convex lens has real focus, so it can able to form all kinds of image. We have two kinds of image, real image and virtual image. Okay, and three characteristic of image, like it is three types magnified, like smaller image or larger image, clear, or equal image. So convex lens able to form all three kind of size of image, like small, larger, and equal. But concave lens has the virtual focus, so it can only form the virtual images. Second, the image formed by the concave is always smaller in size. Okay. Now, next is image formation by lens. Okay, image formation by lens. Rules for image formation. Okay, first of all, condition for image formation. Condition for image formation. Okay, the condition is should be two rays required come from the lens. Okay, two rays should be coming from object, towards lens. Whatever kind of lenses. Okay, now first rule is the ray which is traveling parallel to the principal axis, ray passing parallel to principal axis after refraction goes from focus. after refraction goes from focus. Okay, that is the ray which is moving parallel to the principal axis. This is principal axis PA. Now, if this is the focus point, then the ray is passing from focus. This is first case. Second, the ray which is passing from focus after refraction goes parallel to the principal axis. I will just explain by using the figure. Suppose this is the first principal focus of the lens, and the ray which is traveling from focus point, okay, after refraction it is observed that it traveling parallel to the principal. Okay, this is the second rule. And third rule is a ray which is passing from the optical center of the lens, it will not deviate, or it will move in the same path after refraction, like this point is called optical center. Optical center of lens. Okay. Similar for concave, just find what is happening in the concave case. A ray which is traveling parallel to it is diverted in the another direction. But when a person, just see, when a person is standing in the second side of the concave lens, when he perceived the light entering in his eyes, then he observed that the light is coming from here. So, in the case of concave, appears to come from here. Okay, the ray which is passing parallel to the principal axis appears to coming from here. Okay, for this, suppose this is okay. Now it will move from here, and for the next case, passing without deviation by the optical center. Now, what is this optical center? Okay. Now, see. Suppose we have a concave lens or either a convex lens. If a ray is traveling from parallel to the lens, and you will know that the light is moving from focus after reflection. Okay, and the second ray which is traveling from the other side, okay, after reflection goes from another focus. Let's say this is the focus point. Okay, this is principal focus 1 and this is principal focus 2 of this lens. Now, when we join the 2 points of refraction initial by each other, then the joining line or diagonal of the reflected points are intersect at a point of principal axis inside the lens. This point is called optical center. Okay, this is optical center. It is clear or not? Now we are going to understand which kind of image formed by the lens, and it is also related to your activity, which is image formation by lens. Okay, now hold on. Next heading is image formation by convex lens. Here we have two relations also, that R is radius of curvature and radius of curvature is equal to 2L, as you learn in your smaller class in 10. Therefore focal length is R by 2, where R is radius of curvature and F is focal length of the lens, and it should be noted for convex lens F is positive and for concave lens F is negative. Reason I will just explain in the previous slide. Now, image formation by convex lens. Okay, now let's see, it is the consider a convex lens. This is principal axis, like as PA. So if this is principal focus 1 and this is principal focus 2, by using this relation between the center of curvature and the focal length, we get at equidistance, this is 2f1, or like this is known as C. It is clear? Similarly, this is 2f2 and known as C2. This is C1 and this is C2. Why these are two? Because there is two refracting surfaces, so the convex lens have two kind of focus, or these are known as principal focus 1 and principal focus 2. Okay, now how many situations we have to form the image by using the lens? So let's say it is a very far point called infinity. This is first location. Second location is very far from C or very beyond to C. This is location 2, and near to C location 3, at C location 4, at in between C1 and F1 it is location 5, at F location 6, and in between optical center and F1 this is 7. So by using the convex lens we can able to form the image at the 7 points. It is clear? Now here 2 points are related to the beyond C. Okay, so we can form the image for any of these. So let's say 3 is not here, this is second or third. Okay, we will form the image for second or third simultaneously with the same image. Okay, now which kind of image we observe? Second thing, just remember it, for human eye or for a normal eye, 6 meter distance, the rays coming for us beyond 6 meter. Okay, 6 meter distance, assume like a infinity point. Distance is infinity for normal. Just remember this. If an object is far about 66 meter or 18 feet, then the light or light ray coming from that object nearly or about parallel to it. Okay, now whenever you form the image, you need to describe the 4 things about the image. First, location of image. For image, you need to describe these things: location of image. Second, nature of image. Nature of image. In nature of image, three characteristics are there. One is nature. First, this is second, nature. Third, orientation. And fourth, size. These are the four things. Okay, now location, near or far. Okay, nature is real or virtual. Orientation, inverted, or electric. Size, small or large or small. These are the characteristics which you need to define whenever you describe a kind of image formed by the lens. Okay. Now we understood about the characteristic of image formed by the. Now you have 6 points. Let's see. This is a convex lens. First is at infinity. Object at infinity. Okay. When the object at infinity, the rays coming from the object parallel to the principal axis of the lens, and those rays are passing from its focus. Okay. So the refracted rays actually meet. Now you can also form the table for it. What we have, let's say we form a table. This we have location. Location of two things. One is object and second is image. Here, after that, here we have nature of image. Okay. Now, in the nature of image, we have three kinds. One is size, second, nature, and third, orientation. Clear? Now, from here you will understand very easily. First is object at infinity. Immediate formed at focus. Here, and because it is incident on focus, so size of image is very small. Very small, like a point. Clear? Now, actual meeting or appear to meeting? So answer is actual meeting. So it is real. Next, orientation. Here we cannot define the orientation of a point. Okay, we will write about the orientation after make some images. This is first case. Second, object beyond C. Beyond C1. Okay. Let's say this is F1, this is C1, this is F2, and this is C2. Clear? Now the object is placed beyond C. Then this is A and this is B. Now object, how to form the image? Suppose we have a point A, and when we draw a perpendicular on the principal axis, then we get the length of image. Clear? Now if a ray of light is traveling parallel to the principal axis, it is very clear that line is passing from focus. Clear or not? Now a ray which is passing from principal focus f1 after refraction goes parallel to the principal axis. Clear or not? Now this is image of point A because light is traveling from point A. So this is image of A, let's say A dash. Clear? Now when we draw a perpendicular on the principal axis, we get the image of B dash. Therefore this is image of AB called A dash B dash. Clear? Now explain the things. Second location is beyond C. Beyond C1. Which kind of observation you would find? The image is formed between F2 and C2. Image location between C2 and F2. Clear or not? Next, size of image is smaller. Clear? Actually means or appear to meet. So answer is actually means, so it is real. Now what you can say about the orientation is very clear, it is inverted. Okay, now second is next we get object at C for the fourth case. Object at C1. What is appearance for it? This is F1. This is C1. F2 and C2. Clear? Object is at C1. This is A and this is B. Now the light ray traveling parallel to principal axis, passing from focus, and the another ray which is passing parallel to the passing from focus F1 after refraction goes from parallel to the principal axis. What you find from here? This is A dash and this is B dash. So tell me about the nature of the image. Third point, object at C1. Now location at C2. Size equal. Okay. Nature, actually meaning is real. And last is inverted. Okay. Next. Done. Next is in between C1 and F1. This is F1, this is C1, this is F2, this is C2. Okay, now the object is between C1 and F1. The light traveling parallel to the lens, principal axis of the lens. After refraction goes from focus. Okay, the light which is traveling from focus after reflection goes parallel to principal axis. What you observe now, when you draw a perpendicular, you will get the image A dash B dash, okay, which is beyond C. Okay, now for fourth condition, between C1 and F1, image formed behind C, not beyond. Behind C2, or you can also say after C2. Next, according to the side, you will observe here it is larger. And next, actually meaning is real and inverted. So, this is an important type of image. This is also important. And next we have object at F. At F1. What happens when the object at F1? So, for this situation, this is F1, this is F2, the object is at F1. Two things, two kinds of image we can able to form for it. I will form for you all the two kinds of image, F1, F2. One is a point object, this only, and second is a length object. When the light is traveling from the focus, principal axis, then it will traveling from parallel to the principal axis. Next, we cannot able to take the image from the F second. So we can assume that one ray which is passing from here, from the optical center. Clear or not? When it is passing from optical center, it is very clear it will not deviate from its path. And it is observed that this distance, this distance, this distance, all distances are equal. Then we can easily say that the two rays which is passing from the lens after reflection are parallel to each other, so they cannot intersect at any point. So we can say the image is formed at infinity. For the second case, a ray which is traveling from focus, it is very clear after reflection goes parallel, and you can also know that the parallel rays never intersect each other. As we increase it anything. Okay, so if you are increase it in the backward side, then you will find not intersect or other thing. So in this case, the image is formed at infinity. So right, fifth point is at F1, at F2, and here we cannot define the side. Here not defined, and this is also not defined. Okay. Next, what we have? Ready? And last and very important type of formation of image. Object in between F1 and O. O is optical center, or you can also see between lens and its focal length. Okay, this is F1, this is C1, this is F1, and this is F2 and C2. The condition is object is lie in between F1 and F2. So if the line is traveling parallel to the principal axis, it is very clear that line is traveling from what focus. Second, the light which is traveling from the focus, let's see, you can easily understood why I am making a new lens. Okay, now second light which is traveling from what, assume that the light traveling from this point is after reflection goes parallel to the principal focus, and third which we can able to take that a light which is traveling from this point. Okay, clear or not? Is not being there. Now these are the three lights. Because of that, I will give you the condition need to two rays coming from object. Now for the last type, for last case, I will take all the three rays. Let's say there is an observer in his eyes all the three rays entering after reflection. Okay, so what the eye can do? So I can do only one kind of thing, it perceive that the light which are entering coming from here. Okay, so light when perceive it, so it is always in the straight line. So this light, this is again, so this is point of intersection, and for this case this is point of intersection. Okay, so this is location of A, so we call A dash, and this is E. For this what we can write? Between F1 and optical center, image formed beyond lens. Beyond lens. Or you can also write for this in the same side of object. Next, is smaller or larger? So answer is larger. Because this is object and this much is lens. The image formed actually meeting or by, okay, so this is vertical, and last is erected or inverted, so answer is erected. Okay, this is how the image formed by the lens. Now by using this table, what you observe about the comment? At infinity, image at C, object is traveling towards lens, and the image traveling beyond the lens or far from the lens. At C, again at C, between C and F, beyond C. At F is very far, at infinity. So as the object is moving or traveling towards the lens, the image formed by it is traveling away from the lens. This is first nature and very important nature to form the image by the optical benches. Okay, thank you.